Good afternoon everyone. Today I am going to discuss about the computer network subject, Unit 4. In previous video we have discussed about the transport layer services and some elements of the transport protocol like addressing, connection establishment, connection release, error control, flow control, multiplexing, recovery. These are the different things we have discussed in the previous videos. Now I am going to continue the video. Unit 4, that is Internet Transport Protocol UDP. Okay, Internet Transport Protocol UDP. So what is mean by UDP? The Internet has two main protocols in the transport layer, a connectionless protocol and a connection oriented one. So the connectionless protocol is UDP, the connection oriented protocol is TCP. In connection, why we are UDP is connectionless protocol. So connectionless means even we doesn't need to establish a connection. So it directly communicate with that connectionless. Connectionless means we don't need to establish, and it doesn't have any retransmission. Okay, if any data lost, the data will be lost. It doesn't have any retransmissions. Okay, again it doesn't wait for a acknowledgement. It just communication will be occurred between both the devices, sender and the receiver. Okay. So if we talk about the TCP is a transport control protocol. So in this TCP, the communication will be, first we have to listen and we have to establish a connection, and then we have to if any data is not reached at the receiver, the retransmission will be occurred, acknowledgements will be necessary. So everything will be necessary in this TCP. Okay, so this is that is why this is a connection protocol, and TCP is a connection oriented protocol. Okay, so internet okay, so the connection oriented protocol is a TCP. It does almost everything. It makes connection and adds reliability with retransmission along with flow control and conjunction control, all on behalf of application that use. So since UDP is a transport protocol layer and typically runs in a operating system, and protocols that use UDP typically run in the user space, and these users might be considered applications. So now I am going to give the introduction to UDP. So what is mean by UDP? So the UDP is a user datagram protocol. So the internet protocol should support a connectionless transport protocol called UDP. Okay, so user datagram protocol. UDP provides a way for application. UDP provides a way for application to send encapsulated IP datagram and send them without having to establish a connection. So already I told that without establishing a connection, I am just sending the datagram. Okay, IP internet protocol without any establishing the connection. So UDP transmit the segments consisting of whatever the data we are transmitting, that consisting of 8-byte header followed by the payload. The header is shown in the figure. Okay, I am having the small diagram here. So this is the source port and this is the destination port. So in this when an UDP arrives, packet arrives, it payloads is handed to the process attached to the destination port. This attachment occurs when the bind primitive without the port fields, the transport layer. Without the port field, the transport layer would not know what to do with each incoming packets. So with them, it delivers the embedded segment to the correct applications. Okay. So in this source port is nothing, the source port and destination port, two things we are having. So what is the use of this? It identifies the endpoints within the source and destination machines. So that is called the source port and destination port. UDP length means it includes the 8-byte header and data, and UDP check means it includes the UDP header, the UDP header and the UDP data padded out to an even number of bytes if need be. It is an optional field. Okay, UDP check. Okay, so checksum. Okay, these are the explanation of this diagram. So this is the UDP header. The length of the I told that the UDP length is field is 8-bit header and the data, the minimum length of 8 bytes to cover the header. Okay, so the maximum length is 65,515 bytes. An optional checksum is also provided for extra reliability. It checksums the header and the data. Okay, header and the data. Next, coming to UDP does not support. UDP does not support flow control, error control, or retransmission. In TCP, it supports the flow control, error control, retransmission, and conjunction control. Everything will be supported by the TCP. The UDP does not support flow control, error control, or retransmission upon the receipt of a batch segment. All of that is a user process. Okay, the application that need to have precise control over the packet flow, error control, or timing must have additional layer onto UDP to provide such service. Okay, so this is called the UDP protocol. Okay, so next, coming to remote procedure call. What is mean by remote procedure call? So in certain cases, sending a message to a remote host, sending a message to a remote host and getting a reply back in a is a lot like a function call in a programming language. In both cases, you start with one or more parameters and you get back a result. Okay, you get back a result. So in this this is to be arranged request reply. So this is to be arranged in the request reply interaction on network to be cast in the form of procedure call. So for example, just imagine a procedure named get IP. Okay, just imagine that a procedure named get IP, that is called host name, that works by sending a UDP packet to a DNS. DNS is to a DNS server. So and waiting or the reply, timing out and trying again if one is not forthcoming quickly. So enough. In this way, all the details of networking can be hidden from a programmer. So this is the one example. The observation has led people to try to arrange the request reply interaction on the network with a cast form of procedure calls. Such an arrangement makes network application much easier to program and more familiar to dealing with. Okay, so RPC means remote program procedure call, is used for call a remote program, to call a remote program using the procedural call when a process on machine 1 calls the process on machine 2. So the calling process on 1 is suspended and execution of call procedure takes place on 2. So it means what? Procedure 1, procedure 2 here taking. We can say it is assume that you can say source and destination. At source machine calls the source destination machine. So the calling process which had came the request that is accepted by the machine 2. So information can be transported from the caller to the callee in parameter and can come back in the procedure result. So no message passing is visible to the application programmer. The technique is known as remote procedure call. So whatever the communication is occurring between the two devices, that communication is not visible to the user. Okay, that is why you can say it is a remote procedure call. Okay, so whatever the message is passing between the two devices through the parameters, that is not visible to the application programmer. Okay, that is why it is a remote procedure call and has become the basis for many networking applications. Okay, so similarly the server is bound with the procedure called the server stub. Okay, the server stub, the procedures hide the fact that the procedure call from the client. Okay, client to the server is not local. The actual steps is making on RPC as shown in the diagram. So this is the diagram having client and server. So what here, this is the client CPU and this is the server CPU. So client stub, this is a client stub and this is a server stub. Here we are using the operating system both sides. Okay, first what we are doing, this is the client. Client is client. So what is the step 1? The client is calling the client stub. What is the first step? Here in the first step only, first one here observing here we. So client will calls the client stub. This call is local procedure call. This call is a local procedure call. Within these parameters pushed on the stack in the normal way. So at the step 2, this is the step 2. In the client step, what are the client information is there? The client stub is packing client stub is packing the parameters into a message. Client stub is packing the parameters into a message and making a system call to send the message. Making a system call to send the message, packing the parameters is called marshalling. So now whatever the information I have packed, that is marshalling, and parameters are passed to the operating system, and it moves to the server CPU. Okay, operating system sending this operating system is what doing, the whatever the information message is having, that sending the message from client machine to the server machine. So at operating system passing the incoming packet to the server stub. So whatever the information available here, that information is passes to the server stub. Okay, so in the server stub calling the server procedure with the unmarshaled parameters, the reply traces the same path in the other direction. Okay, say whatever the procedure is occurred, that can be done here, okay, in the reverse manner. So the key item is, note that here is that the client procedure written by the user just makes a normal that is local procedure call to the client stub, which has the same name as the server procedure. Since the client procedure and the client stub are in the same address space, the parameters are pushed in the usual way. So similarly, the server procedure is called the procedure in its address space with the parameters. It expects to the server procedure nothing is usual in this way. Instead of input output being done on sockets, network communication is done by faking a normal procedure call. With RPC, passing pointers is impossible because the client and server are in different address spaces. Okay. So next, coming to the real-time transport protocol. So what is meant by real-time transport protocol? So in this client server RPC remote procedure call is one area in which UDP is widely used. Another one is real-time multimedia applications. So in particular, internet radio, internet telephony, music on demand, video conferencing, video on demand, and other multimedia applications become more commonplace. So there are two accepts of RTP, remote RTP. So to consider, the first is the RTP protocol, for transporting RTP, remote transport protocol, I think. Okay, transporting audio and video data in packets. So the second is processing that takes place mostly at the receiver to play out the audio and video at the right time. So RTP normally runs in the user space over UDP in the operating system. It operates as follows. So this is called real-time transport protocol. So the multimedia application consisting of multiple radio or audio, video, text, and possibly other streams. These are fed into the RTP library, so which is in user space along with the applications. This library multiplexes the streams and encoded them in RTP packets, which it stuffs into a socket. Okay. On the operating system side of the socket, UDP packets are generated to wrap the RTP packets and handed to IP for transmission over a link such as Ethernet. So the reverse process happens at the receiver. So reverse procedure is happen at the receiver side. The multimedia applications eventually receives multimedia data from the RTP library. It is responsible for playing out the media. The protocol stack for this situation. So the packet nesting is shown in the diagram. So this is the RTP multimedia applications, user space, and this is a socket interface. UDP here, IP Ethernet. This is operating system kernel, and Ethernet header. This is the IP header. This is a UDP header, and this is a RTP header. So RTP payload. Okay, and the position of RTP in the protocol stack. Packet nesting. This one. Okay, so packet nesting. So this is the diagram. So next one is the basic functions of RTP is multiplex several real-time data streams onto a single stream of UDP packets. In particular, there are no special guarantees about delivery, and packet may be lost, delayed, corrupted, etc. So the RTP format contains several features to help receivers work with multimedia information. If a packet is missing, the best action for the destination to make is up to the application. It may be to skip a video frame. If the packets are carrying video data or any approximate the missing value by interopolation if the packets are carrying audio data. Retransmission is not practical option since the retransmitted packet would probably arrive late to be useful. As a consequence, RTP has no acknowledges and no mechanism to request the retransmission. So this is called the remote procedure call. Next coming to transmission control protocol, TCP. So what is mean by TCP? Up to now we are talking about the UDP. Now I am talking about the TCP, transmission control protocol. So it was specifically designed to provide a reliable end-to-end byte stream over an unreliable network. So it was designed to adapt dynamically to properties of inter-network and to be robust in a face of many kinds of failures. So each mission supporting TCP has a TCP transport entity which accepts user data streams from local process, breaks them up into pieces not exceeding 64 kilobytes and spends each piece as a separate IP datagram. When these datagrams arrive at a machine, they are given to TCP entity, which reconstructs the original byte streams. It is up to TCP to time out and retransmit them as needed. Also to reassemble datagrams into messages in proper sequence. Okay, so in this UDP is a simple protocol and it has some niches uses such as client server interaction and multimedia, but for most internet applications reliable sequence delivery is needed. UDP cannot provide this. So TCP transmission control protocol is used in internet. The main contents of this TCP is introduction to TCP, the TCP service model, the TCP protocol, the TCP segment header, the TCP connection establishment, TCP connection release, TCP sliding window, TCP conjunction control. So these are the different contents available in the transmission control protocol. So what is mean by TCP service model? So introduction we have discussed in the previous. Now I am going to introduce the TCP service model. So what is mean by? So this is the introduction to TCP. So each mission supporting the TCP, has a TCP transport entity, either a library processor, a user process or a part of kernel. So in all cases, it manages the TCP streams and interfaces to the IP layer. A TCP entity accepts user data streams from local process, breaks them up into pieces not exceeding 64 kilobits and sends each piece as a separate packet, and it provides a reliable end-to-end byte stream over an unreliable internet work. This is called introduction of TCP. Next coming to TCP service model. TCP is obtained by both the sender and the receiver. Creating points are called sockets. So sender and receiver, we are creating both sender and receiver sockets. Receiver, each point called, we can say it is a sockets. Each socket has socket number, that is address, consisting of IP address of the host and 16-bit number local to the host called a port. For TCP service, okay, so to obtain TCP, a connection must be explicitly established between a socket on the sending machine to socket on receiving machine. All the TCP connections are full duplex and point to point, that is multicasting or broadcasting is not supported. A TCP connection is a byte stream, not a message stream, that is the data is delivered as chunks. So the TCP service to be obtained, a connection must be explicitly established between a socket on the sending machine and a socket on receiving machine. Okay, so each socket has a socket number address consisting of IP address of the host and the 16-bit number local to the host called a port. This is called TCP service model. So this is the list of the listed of the socket calls. So I having the socket, bind, listen, accept, connect, send, receive, close. So what is mean socket? We are creating a new communication endpoints, that is called socket. Okay, that is called a socket. Okay, So a socket may be used in multiple connections at the same time. In other words, two or more connections may terminate at the same socket. Connections are identified by socket identifier at the same socket. Connections are identified by the socket identifiers at both ends. Some of the sockets are listed below here. So this is the socket. So port number below 256. So before going to explain that, socket is creates a new communication endpoints. Bind is associating a local address with a socket. Listen, we are announcing the willing links to accept the connection. Give queue size, accept, passively establish an incoming connection. Connect, actively attempt to establish a connection. Send some data over the connections. Receive some data from the connection. Close, release the connection or terminate the connection. So these are the different socket calls are listed in this table. Okay. So next I having some ports. So these are the ports. A socket may be used in multiple connections at the same time. Port numbers below 1024 are called well-known ports and reserved for standard service. For example, this is FTP is a file transfer. FTP is used for file transfer and remote login replacement for telnet, email, HTTP, World Wide Web, POP3, remote email access, IMAP, remote email access, HTTPS, secure web, RTSP, media player controller, IPP, printer, sharing. So these are the different ports are there. So port 21 and port 23. Port 21 establishes the connection to be host to the transfer a file using FTP. Port 23 is to establish a remote login session using telnet. Okay. So this is called the ports we are having. So in TCP, next to TCP protocol. A key feature of TCP and one which dominates the protocol design is that every byte on the TCP connection has its own 32-bit sequence number. So when the internet began, our lines between routers were mostly 56 kilobits per second, leased lines. Okay. So the host blasting away a full speed took over 1 week to cycle through the sequence number. So the basic protocol used by TCP entities is the sliding window protocol. When a sender transmits a segment, it also starts a timer. When the segment arrives at the destination, the receiving TCP entity sends back a segment bearing an acknowledgement number equal to the next sequence number it accepts the receive. So if the sender's timer goes off before an acknowledgement is received, the sender transmits the segment again. Okay. So this is called the TCP protocol. Next, TCP segment header. What is TCP? Every segment begins with the fixed format 20 byte header. So the fixed header may be followed by the header options. Therefore, the option if any up to 65,535 to minus 20 is equal to 65,495 bytes may follow. So there are where the first 20 refers to the IP header and the second to the UDP header. Segment without any data are legal and are commonly used for acknowledgement and control message in the segment header, TCP segment header. So in the fixed so I am having the diagram for this TCP. This is the diagram having 32 bits and source port and destination port. It identifies the endpoints of the connection, sequence number. So sequence numbers of the segment. We are specifying the sequence numbers of the segment. TCP header length tells how many 32 bits words are considered in TCP header. URG means it is a set to 1 if urgent pointer is in use, which includes start of urgent data. Okay. Acknowledgement, it is set to 1 to includes that the acknowledgement number is valid. PSH, push, indicates pushed data. RST, reset a connection that has become refused due to reject an invalid segment or refuse an attempt to open a connection. Fine, used to release a connection. Sign, used to establish a connection. So these are the different yeah, information available in the TCP header. Okay, so this is the TCP header diagram. Suppose the source port and destination port is identify the local endpoints of the connection. TCP port plus its host IP address forms a 48-bit unique endpoints. The source and destination endpoints together identify the connection. This connection identifier is called a 5-tuple because it consists of 5 pieces of information: the protocol TCP, source IP and source port, and destination IP and destination port. So the sequence numbers and acknowledgement number fields perform their usual functions. So the TCP header length tells how many 32 bits words are contained in TCP header. The function is needed because the option field is of variable length, so the header is 2. Okay, header is. So next comes to 6-bit field that is not used. URG is set to 1. If the urgent pointer is in true use, the urgent pointer is used to indicate a byte offset from the current sequence numbers at which urgent data are to be found. Acknowledgement bit is set to 1 to indicate that acknowledgement number is valid. If acknowledgement is 0, the segment does not contain an. So the PSH push bit indicates pushed data. The receiver is herely implied requested to deliver the data to the application upon arrival and not buffer it until a full buffer has been received, which it might otherwise do for efficiency. So our reset means bit is used to reset a connection that has become confused due to the host crashes or some other reasons. So synchronized bit is used to establish connection. The connection request has synchronization equal to 1 and acknowledgement equals 0 to indicates that the piggyback acknowledgement field is not in use. The connection reply does bear an acknowledgement, so it has synchronous equal to 1 and synchronous acknowledgement equal to 1. As in sense, synchronous bit is used to denote connection request and connection accepted, with the acknowledgement bit used to distinguish between those two possibilities. CWR and ECE are used in a signal conjunction when explicit conjunction notification is used. So fine is another entity. So fine bit is used to release connection. It specifies that the sender has no more data to transmit. However, after closing a connection, the closing process may continue to receive data indefinitely. So both the synchronous and fine segments have sequence numbers and thus guaranteed to be processed in the correct order. So flow control is TCP is handled using variable size sliding window. The window size fields tells how many bytes may be sent starting at byte acknowledgement. So HXM is used. HXM is also provided by the extra reliability. It checksums the header and the data. It's called checksum. So next coming to TCP connection establishment. So to establish a connection on one side, say that server passively waits for an incoming connection by executing the listen and accept primitives, either specifying a connection source or nobody in a particular. So to other side, say the client executes connect primitives specifying the IP address and port to which it wants to connect. The maximum TCP segment size is willing to accept and optionally some user data, example password. So the connect primitives used a TCP segments with synchronous bit on the on and acknowledgement bit of and waits for a response. Okay. So in this connection establishment, already I told that connection same as, but in this we are having retransmission. So we are establishing a connection on site. Say the server passively waits for an incoming connection by executing the listen and accept primitives, either specifying a common source and or nobody in particular. So the other side, say the client executes a connect primitives specifying the IP address and port to which it wants to connect. The maximum TCP segment size is willing to accept the optionally TCP segment size. Optionally, some user data, data is example password. The connect primitive sends a TCP segment with the synchronous bit on and AC acknowledgement bit off and waits for a response. Okay, this is called TCP connection establishment, same as. So, for this establishment, we are providing the connection request primitive to the server to destination. Destination will be reply for that, and he give the another data. Whenever the data is not reached, again it waits for a time for an acknowledgement. If it doesn't get any acknowledgement from the data which has sent to the sender to, so again it retransmitted. Okay, so and password. And okay, this is called a TCP connection establishment. So, when this segment arrives at the destination, the TCP entity that checks to see if there is a process that has done a listen on the port given in destination port field. If not, it sends a reply with the reset with on to reject the connection. If some process is listening to that port, that process is given incoming TCP segment. It can then either support to reject the connection. If it accepts, an acknowledgement segment is sent back to the sequence of TCP segments in a normal case. So, note that a synchronous segment consumes 1 byte of consequence space, so that it can be acknowledgement ambiguously. So, this is the host 1 and host 2. I am sending the synchronous with sequence number x to the host 2, and host 2 is sending the sequence number regarding the host 1 with acknowledgement x plus 1 and sequence number of y host 2, and again he is sending the data along with his sequence number x plus 1 and acknowledgement y plus 1. So, this like the communication will be occur. So, at host 1 and host 2, this is the second diagram. So, TCP connection established in the normal case, simultaneous connection established on both sides. So, both sides we can send each other. So, host 1 only is not have responsibility to send the request. Host 2 also have responsibility to send that. So, when whatever wish they are at a time, they are sending the data. At a time they are sending the data. This like the cross so simultaneous connection is established on both sides. So, next TCP connection release. So, coming to TCP connection release. So, this TCP connection release will be discuss the TCP connection or full duplex. To understand how connections are released, it is best to think of them as a pair of simplex connection. Each simplex connection is released independently of its sibling. So, to release a connection, either a party can send a TCP segment with the fine bit set, which means that it has no more data to transmit. When an fine is acknowledged, the direction is shut down for a few data. Data may continue to flow indefinitely in the other direction. However, when both directions have been shut down, the connections is released. Normally, 4 TCP segments are needed to release a connection on fine and one acknowledgement for each direction. This is the connection release. Connection release means in the simple way, if you want to terminate the connection, we just release the connection. Okay, we just terminate the connection. Okay, so that is called the TCP connection release. So, okay. So, thank you. In the next class, I will continue the next one, that is TCP sliding window protocol, its diagram, TCP conjunction control, and performance problems in the computer, and network performance measurements. These are things will be discussed in the next class. Thank you, everyone.